We are talking about Cerebase, and we have Mr. Aditya Singh from J&J who is going to talk about Cerebase and why it is an innovative catheter system. Please, Mr. Aditya Singh.
Hi everyone, I'm Aditya. I work for Johnson & Johnson, a division called Cerebase. I can see very familiar faces here. I've been meeting them over a period of around 20 years. I've been working in neurointervention field in sales and marketing. I must thank and congratulate the organizer of this meeting for having a very different kind of meeting. Very innovative, especially when neurointervention is a field is innovating so fast. Okay, every 6 months there are some innovation that are coming in the market. So without taking much of the time, I'll just go and discuss about the Cerebase DA sheath, what exactly it is. So this is about the technical overview of. So what we're going to talking about, we'll be talking about the design element and the design feature. So everybody is working with the base catheters. So initially it was guiding catheters. Then came the distal access guiding catheter, which were serving as base catheters, balloon guide catheters for ischemic stroke, and then came the long guide sheaths, which will go up to cervical. So what was offered by a long guide sheath was large in a diameter to accommodate different treatment options. As the complex procedures have been operated, multiple devices were used. So we required something which can take multiple catheters and go very distal. So it was traditionally tracked to the cervical segment of the ICA, trackability to navigate into vasculature and stability to support neurointervention. So this is like base catheter, then the intermediate catheter, micro catheter, and a guide wire. So what was required was something which can go reach up till here in the first petrous bend. So Envoy DA distal guiding catheter could reach that, and guide sheath Cerebase DA. So these are the regular base catheters which will go up to cervical portion. Coming on to creating a distal category for long sheaths is like now. So most of the time proximal placement is done here with older sheaths like shuttle or arrow sheaths. They would place it somewhere here. With the next generation sheath was standard placement, which was in the cervical. So what does distal access sheath has to offer? You can take them right up to the petrous bend, or you can park into the cervical with a bend. They are very, very supple and take these bends. So right now it's like around 15% of the doctors are trying to place them here. This is how a Cerebase packaging looks like. This is a Cerebase catheter. It's a dilator here, and then there's a hemostasis valve, which is a very small one. where it would save you a lot of length for the other catheters. So this is what is marked. Please don't get confused with the 8 French. It is a 6 French sheet with 8 French outer diameter. It comes in various sizes. In India, it is available in 80, 90, and 95 centimeter. Okay, with inner diameter of 090 and outer diameter of 8 French. The design element. So it very uniquely, what Cerebase did was they had this tip, 2 centimeter of dex tip, and then 20 centimeter of hydrophilic coating. There's a marker here, which is 1 millimeter away from the tip to visualize the sheet placement, the strain relief, and the hub. It's a hub lure where if you're using for multiple catheters, you can use a W connector or a Y connector or a single to-heat for stroke intervention. So this is how the cross section of the Cerebase looks like. There's a outer hydrophilic coating which is on distal 20 centimeter. Then polymer of varying durometer. So this is very important because this durometer provides softness and where it's required on the distal portion, and on the proximal portion the stability. There's a braid running all across the body of the catheter, and then inner PTFE lining. So this is a stainless steel braid wire which is from the tip to the hub of the catheter. So I'll just talk about this. This is the PTFE lining which is inside the catheter, which balances the lubricity and durability of the device for the device exchanges. There's a complete braid which is from the tip to the hub of the catheter. The important thing is that that it has continuous density. Means PPI is constant in the entire length of the catheter, not like variable braids. So it is very continuous in density of this braid. The softness and the stiffness of the sheet is with the durometer. So there are multiple segments for a smooth transition. There are 12 segments in the polymer jacket, and the hardness of the polymer used main determinant of the stiffness of the flexibility of the segment. So how it fares on the how it fares on the softness of this, and it is stiff where it's required to give a lot of support at the exchange of from aorta to the common carotid. So distal 20 cm contains majority of these transition in order to provide more trackability in distal tip. Dex tip is very, very soft. It can take very acute bends. So it's like articulating bus. So it can take these kind of turns. And why it can do that is, if you see this is Cerebase, which can take turn. And this is a competition catheter, which is still a little stiffer than this. So, to sum it up, go distal, park this in the petrous segment or in cervical where there is some tortuosity to get more support. It can track, it can take a lot of bends, and we've been getting a lot of feedback on the ability of Cerebase. Thank you very much. So you can park it in some kind of tortuosity where so there are two things. What length do you use? Okay, because there's a 20 centimeter segment which is the hydrophilic coated. So we would recommend to park the sheath in.
Sir, I just wanted to know. Here, sir. The hydrophilic coating that we are talking about in the sheath, that is on the outer aspect, correct?
Yeah.
So, does it mean that whenever we take this catheter system for usage, we need to wet this before we take it in?
I mean, yes.
So, you always recommend wetting this in a tray before we take it up?
So generally, in my experience, everything which is removed is wetted and then it's used onto the patient. But there is no time limit that it needs to be wetted for 20 seconds or 30 seconds or 60 seconds.
And another question that we were asking is when we were talking about the other guiding sheets that were there, it was talking about the difficult loops, those 360 degrees and 260 degrees. And you had showed those articulating systems that were there. So my understanding is that even if you use a slightly lengthier guiding sheet system, we'll be able to cross these loops? Is that recommended or we are not supposed to do that?
What I would, generally what happens is, it depends on the patient anatomy. That's 20 centimeter segment which is going to take all the loops and everything. Okay, it depends. Then you'll have extra length. So if the patient's short enough or you have a proximal tortuosity in the proximal ICA, we would recommend to use a 90 centimeter than a 95 centimeter.
Okay.
So that it will take those loops and everything. I'll be able to show you a lot of pictures where people have used it in very difficult kind of situation and used along with the length.
So my question was only that. So you are okay with us using those the catheters for the loops? Is that okay from the company? Yes. Meaning it's recommended for those because the DEX technology that you were talking about, the 20 centimeters, are meant to cover those loops.
So DEX tape is 2 centimeter.
Okay.
Just to take those bends.
Okay.
So once it takes the bends, then the catheter follows. Okay. Then there are different channels. The softness decreases. Once you come proximally.
Okay.
But DEX tip is the one which takes a lot of turns and that enables you to take these turns in the vasculature.
So, okay.
Yeah, for the benefit of everyone, can you just elaborate on, you say it is 6F and then it is 8F and the inner ID is more. Can you just elaborate and the compatibility with the guiding catheter, the femoral sheath also, which sheath should be used?
So, as I shown, on the packaging itself, it says 8F. 8F is the outer diameter of the. It's a 6 French sheath, with 8 French of outer diameter. Okay. So if you have to place a small sheath, a short sheath, it will go through a 8 French sheath. And the inner ID is 090.
6 French sheaths are the one, and 8 French catheters. The guide catheters, 8 French and 6 French, is the combination, right? So a 6 French sheath is a sheath that can accommodate a 8 French guide catheter, a 6 French guide catheter. So a Navian is a 6 French guide catheter. A 6 French sheath can take a 6 French guide catheter. So this is where now if you call it a guide catheter, the terminology will be like, oh, I have to call it 8 French as a guide catheter, I do the OD. As a guide sheath, I do the ID. Does that make sense? Yes, no?
Yeah, just to clarify that.
Yeah. And interestingly, this is a debate. This is a lot of confusion, okay? We are all learning through this. Is like, why? And now you will see that there are other sheaths. They are used as sheath, but they are cleared as guide catheter. Their labeling is like a guide catheter, but it's a sheath. And this is regulatory also we are dealing with those type of issues.
Yeah, exactly. Same. That's the reason, because it's been called as a guide sheath. That's the reason they have mentioned the outer diameter rather than just the sheath which is like inner diameter.
Yeah, this is for everyone.
Yeah.
I usually tell my fellows, like every company will say that it will take a 180 loop, 360 loop, it can go as distally as possible. But suddenly when you start doing it, it will get stuck. It does. For the vessel to prime. Without priming the vessel, you try to track any catheter up, it's going to create severe spasm only. So the main thing is to keep it down, give some time, let the nimodipine flow, let the vessel be primed, then you can take any catheter slowly along any turn. But trying at the first go itself, trying to take up as distally as possible, you might be able to push it up, but you find that the vessel is fully in spasm. Absolutely. And you can't do anything beyond that.
Very true. And one thing that we have learned is, especially taking around those curves, we have seen that they try to reduce the ledge. So if there is something that is very closely that tracks over there, over that they will take a 6 French DACs or like aspiration catheters. If they are there, then they see how the vessel is responding, and then very gently. So again, there is not yes or no answer. It's how you are practicing.
Thank you very much.